Thank you very much for the greeting and the invitation. So, infrastructure value and the case for innovation. Really what I'm going to talk about this evening for a little while is change in the engineering that we do. And I'm going to talk about it in the context of London's transport system. I'll start off with a bit of sort of scene setting, a bit of why I've been thinking about this topic and a bit about our heritage. But then most of what I want to talk about is the process of engineering change. What drives it? How do we achieve it successfully? And then I'll give you some examples of some of the things that have quite excited us, or at least excited me, in the work we've done in the Transport for London, London Underground world. And we'll end with some thoughts about the future, where we might be going beyond current projects. So that bit of context and heritage. Well, you've just heard a few kind words about me. My natural habitat is, professionally, it's wet, muddy, there's not much daylight, it's about 30 metres down typically. I've spent my career around holes in the ground. Bit of time on design, quite a lot of time on construction, but also quite a lot of time operating them and maintaining them, which I actually find quite an unusual viewpoint. So that's where I'm coming from. Just had reference to the Channel Tunnel Rail Link, high-speed one. It's a good example of the sort of thing I've enjoyed doing during my career, and where I think as engineers we've been able to bring quite a lot of innovation into the delivery of a transport system that can make a real difference to areas of the country, and in this case international travel. So it was a railway nearly 70 miles long. It took us about 9 years in total to build it. Like a lot of big engineering projects, it was a multinational engineering consortium that delivered it. We worked to the standards of the time, developed, tuned to our particular needs. And these days it's managed by a dedicated maintenance organisation. So there we are, there's a quick pen picture of a piece of linear infrastructure. Most of what I deal with is linear, it's road and rail. And you find linear systems have some common characteristics. So that's a job I certainly feel very proud to have been involved in, and I know a lot of my colleagues do. But I started thinking a bit earlier this year about what I might talk about tonight. And I was actually on another piece of linear infrastructure at the time. I was actually up on Hadrian's Wall with my sons. Now here's a piece of linear infrastructure. It's about 70 miles long. It took about 6 years to build this one. Interestingly, it was standardised design. The forts are just the same wherever in the Roman Empire you look. It was a multinational engineering contractor. I think that's a fair term for a number of Roman legions. And they didn't dirty their own hands with maintaining it. They got a DLO organisation to do that. And I stood there on Hadrian's Wall up at Housesteads and thought, actually, this is remarkably familiar, isn't it? And I actually thought, well, 2,000 years on, we might manage to build something slightly shorter that took us a bit longer to do. We didn't have quite the same lifetime expectation, and our delivery model was perhaps similar. I found that a fascinating comparison. It really made me think about what changes in our industry. Because on the face of it, you could look at that and say, well, where's the progress? Why couldn't we do it in 6 months or build twice as much or whatever? And of course, when we drill into it, the engineering is quite different in the detail. But it set my mind going on change, and also reminded me just what impressive engineers the Romans were. So let's have a think about some of the engineering heritage a little bit closer to home for London Underground. We do have a great history, great heritage of innovation within the London Underground system. If we go back to the earliest days, almost 200 years ago, the oldest tunnels that we currently run trains through were, of course, constructed by the Brunels using their newly developed tunnelling shield. It took them a long time, they had some mishaps along the way, but it was undoubtedly innovative work. And then, of course, 1863, the first metro system in the world. Famous picture of the luxury transport for the VIPs at the opening at the top there. And down at the bottom, just a couple of years ago, we had great fun with one of the restored locomotives and early carriages, recreating some of the early scenes from that railway. And of course, metros have spread through the world, taking the name of our Metropolitan line with them as the tagline. We pioneered the deep electric tube. This is the City and South London Railway. We're still only in 1890 here. This is a long time back. We're more than a typical civil engineer's design life ago, but we had electric underground railways opening up in our city. If we leap forward a bit, let's leap into the last century, the 1960s here. The first automatic railway was another major breakthrough, and again a concept that's been repeated around the world. So you can see here Her Majesty in the cab of the train pushing the button to set the thing going. And down on the bottom right, more recently, we've renewed this railway. That was another new challenge, the first time anybody had actually fully renewed an operating automatic railway, new trains, new signals, without taking it out of service. So change all the time there. Of course, if we dive into the civil engineering, get closer to my sort of home territory in the tunnelling, lots has changed there. Materials have changed, methods have changed. In the early days, it was a cast iron structure or a masonry structure. These days, most things are concrete, whether it's high specified precast concrete like the segmental tunnel there, or increasingly sprayed concrete. And it's delivered with complex computer-controlled systems, whether it's controlling the erector of the segments or the spraying of the robot on the left. The little graphic at the bottom is the sort of graphic that nozzle man spraying the concrete can be seeing, can be using to guide him where he's sprayed too much or too little. And as all these technologies have come along, frankly, we've got greedy. We have asked for more and more out of these systems. And this just shows you graphically how the sizes of running tunnels have changed in London. So the Tower subway, not in fact part of the underground system, a slightly earlier railway, down at 2.1 metres, was a triumph at the time it was created. As the tube network was delivered, we successively got larger and larger, greater expectations, come through to the Victoria line and the Jubilee line extension. We were starting to think about walkways and so forth, getting bigger all the time. And then recently we've delivered the CTRL and Crossrail with much larger tunnels again. So we're ambitious for what we want to achieve. So there we are. I said my theme was change. Do we need to change? Before we dive into the actual engineering changes in a bit more detail, let's think about why we might want to change in London's transport system. This is a population graph for London. Sort of thing you might have seen presented around about 1980. And you can see that when the Brunels were tunnelling under the river, right back at the start of this story, there was a little over 1 million people resident in London. And the population grew steadily right up to the time of the Second World War. And it reached a peak up around the 8 million mark. But then after the war, it changed. There was the disruption of the war itself. There was social change after the war, development of new towns. There was decline in industrial areas in the city. And the population dropped away with those things. And it was expected for quite a while that that trend would continue. But London had a surprise. If we look back now, we see a change in that trend again. Around about 1980, 1981, the population decline reversed. Those who were around the city at the time will remember Canary Wharf as a key development of the era and a sort of a figurehead for change there. And since that time, we've seen steady growth to the point that earlier this year, London's population has actually reached its highest level ever. we're now back up at around 8.5 million, and we're planning actively for a city of 10 million in the fairly near future. And with that, we're seeing change in transport demand. And you can see the graphic there showing how the transport demand is changing. Cycling's racing away there. Of course, that's the trend. The total number of cyclists is still relatively low. Public transport usage rising greatly, and the car flatlining. So that tells you something about the demand for infrastructure in the city. If we look at that Canary Wharf area, this is a little summary of what happened there. The top left, 1981, the start of this growth period. 3,000 people worked in that area. 1987, top right, the Docklands Light Railway opened, the first transport system coming new into the area. And the working population was starting to grow. By the millennium, the Jubilee Line extension got there, and the working population was nudging towards 100,000. So there's a close correlation between the population growth, the working population growth, and the transport making the area accessible. If we look forward in the last case there to 2018 and the opening of Crossrail, we're looking at a further doubling of the working population in that area, back up to around 200,000. So transport and growth and change are intimately linked in this city. The Greater London Authority publishes a London Plan which highlights areas within the city, and they're marked in the rings here, where there is a particular expectation of growth. That might be growth in employment, it might be growth in housing. They're both big drivers. So areas like the Thames Corridor has been identified as potentially growth both types. The Lee Valley going up to the north is seen as likely to be a dominant growth area for housing. Greater London Authority would like to see another 200,000 homes in the city in the relatively near future. These are some of the areas where these things will focus. And it tells us about demand. So TfL, Transport for London, is responding, of course, to that with a variety of proposals. We're reflecting the transport, or the public transport growth that I showed you projected in that graph, with a whole series of schemes like the Crossrail lines, Crossrail 2 that we're currently developing on the right there, Crossrail 1, of course, now well on the way to delivery. Schemes like the Northern Line extension, the LU station upgrades, and some strategic highways work like the Silvertown Tunnel, which will provide an additional river crossing in the east of the city, opening up connections for that area. So we see those projects driven very much by demand. But I think we should think big, think beyond those immediate things. It's quite informative to look at what other cities around the world have done with underground infrastructure. There's a little compilation here of a number of cities where essentially transport systems, highways in particular, have been pushed underground to free up space at the surface, often to be used as green space, but sometimes for other purposes. These kind of ideas become very important when you're looking at the sort of magnitude of growth that we're looking at. And they're a challenge for the people providing the infrastructure. So one particular case being talked about a lot in the Greater London area is the Hammersmith junction, where currently we have a somewhat troubled flyover shown in the top picture there. And it's been suggested that that flyover might be effectively pushed underground and the area at the surface freed up. Not a TfL proposal directly, but certainly the sort of thinking that we're sympathetic to. It's the right big thinking to get ideas going. And I thought, as we were in Cambridge, I thought I'd better mention as well that it's not only London, of course, that goes through this sort of thought process. And there is a lot of communication to do between different cities, both globally and nationally, around how we tackle some of these questions of demand for more transport and communication in our cities. So what do we take from all of that? Well, it's quite a simple equation, really, isn't it? Demand is growing. I've just been demonstrating that, I think. Our expectation is it will continue to grow for as far as we have a reasonable ability to project the numbers. And of course, our resources are finite, whether that's the national purse or any other measure of resource. We know we have a fundamental issue with needing to conserve resource. So we need to squeeze more performance out of the things we do. And fundamentally, that, I would suggest, is why we need to be innovative in this sort of work. So we need to change. Is it easy to change? Well, here's a few examples of innovative technology. I think you probably recognise most of those and remember a bit of the stories behind some of them, whether it's things like the exploding batteries at a fairly small scale or the catastrophe of the Titanic. But they were all bold attempts to take us to new places with pieces of technology, and they all struggled. Some of the failures were technical, some of them perhaps are more about market expectations and that sort of thing. But they demonstrate that it's not always easy to get it right. A little bit closer to my patch, this is a nice one. Sadly, this is a story we actually know very little about, but we know it happened. There are a few photos and there are just a few pieces of mechanical equipment left as evidence. Round about the start of the last century, it was becoming apparent that more and more people were using the underground, and we needed the ability to get them in and out of our underground stations quicker. And in the early days, that had been done by lifts for the deeper stations. There was a need for a better system, and somebody came up with the idea of the spiral escalator, which clearly could potentially fit in the existing vertical shaft. And we have this tantalising picture of these gentlemen trying to put together a spiral escalator. Sadly, most of what we know about this is that it didn't work and they abandoned it. One can imagine all sorts of mechanical agonies in trying to get that going. Perhaps we just then moved our innovation focus somewhere else and learned how to build inclined tunnels, because that was easier than to put an inclined tunnel with a straight escalator in it rather than a vertical shaft with a spiral escalator. Maybe we just found the easiest route. But it is interesting to note now that 100 years later, you can go to the market and you can buy a spiral escalator. So the idea wasn't daft, it was just a problem in the execution there. So, innovation necessarily involves risk. That might be technical risk, it might be like that escalator. Maybe you just can't make the thing work. Or more often, actually, you can't make it work reliably. Or it might be a commercial problem. Maybe you misjudge the market. Maybe you can't see how to get a financial return on the technology you've developed. But the point is, we need, to be successful, we need more than just the good ideas, more than just the technologies themselves. We need to think about the actual process of putting innovation into practice, and we need to try and ease that process along, help it. So lots of organisations have explored barriers to change, barriers to innovation, and there's just a few organisations here I've picked from different sectors who've looked and published stuff on this sort of problem. And there's quite a few common messages you find, and the bullet points on the left here are essentially a summary taken from the IBM document, but you'll find similar listings in various places. And people cite barriers to change as being lack of time, lack of money, silos, by which they mean we tend to work in our own compartments, and if a technology challenges the boundaries between where I work and where you work, we're not as good at adopting that technology as something that fits neatly in our existing silos. Or sometimes we just use the wrong measures. Maybe they give us benefits of a type that we don't actually have a way of quantifying. That can block innovation. And sometimes we're just plain risk averse. And I think all of those things one would recognise to some extent in my sort of professional world, civil engineering, underground infrastructure. There can be some element of all of those things apparent. But also, there are some sector-specific problems that we do wrestle with in the world of tunnels. Ironically, one of our problems is the reliability of our assets and their long asset life. That gives us an issue, particularly in conjunction with the way we develop business cases for innovations. Then we have some other things. We have some soft skills issues that come in. User skills don't marry up necessarily with new technologies. Things we used to do by going and looking and tapping with a hammer, if we now need to do it with a tablet, there's a different set of skills that are needed. That can be a blocker. And there is a huge issue in our sector with that last bullet point there. A suspicion of solutions looking for problems. That tends to be what goes through the mind of most civil engineering asset managers, I would suggest, when they're shown pretty much any piece of technology. Let's just unwrap that first one, though, a bit about reliable assets, because this is actually something that is a very real issue for me, and I see as an issue for an organisation like CSIC, for example. Here we have an asset. This is a tunnel. It's at Euston Station. Once upon a time, trains ran along here, but it's had a complicated history and it's changed its use. So now that tunnel serves to carry a few wires from one place to another, and it's actually a back-of-house footway, effectively. It takes you down to some rooms where various pieces of equipment are held. That tunnel's actually very important to the operation of the railway. It might look simple, but if we didn't have that, we'd have a bit of a problem. But it's a very simple structure. You can probably see there, it might be a little bit dirty, but there's not much else wrong with it. But basically, to be honest, nothing much ever happens in there. Now, if we think about the way we justify investing in new technology, change, it's usually based for us on a model of asset risk. We look at the assets we have, our catalogue of assets. We identify what we would term the behaviours, the ways they might change, the ways they might degrade, and we would convert that into a risk. So we would look at how many years until we need to make an intervention to fix it. If we were on the surface, if we were looking at a metallic bridge, we might figure out a number of years before we needed to go and paint it again, that sort of thing. The problem we have underground is that we need to do very little maintenance to a lot of these. Therefore, the calculated asset risk is very, very low. The asset risk associated with that bit of tunnel might be measured in pence per year, say. Now, if that's the case, it's very hard when you come to make an investment decision to use that risk value to justify your investment, because almost anything you want to try is going to cost you more than the value of the risk. We trip up on that problem repeatedly. Doesn't mean the model's wrong, but it makes you want to ask questions. Is asset risk the right measure? In many ways, it's probably a very good measure. I don't want to do it down, but it has the effect of perhaps tending to stifle innovation in certain situations. So could we change it? Could we bring other benefits? For example, if we had a new condition monitoring technology that provided some other information about that tunnel, perhaps who's down there, that might be of interest to us. How often somebody passes through it. Then we might be able to bring other benefits in, and those might give us a win there. So there's a whole area there. We have to think very carefully about how we present the case for this sort of thing. Then there are other issues. Life cycles is a key one again for tunnels. I've illustrated a nominal 120-year design life there. Hadrian's Wall, that linear asset, they operated for 300 years. We'd like to aspire, we sometimes say, to 400 years life out of our tunnel structures. It's a very long wavelength thing, the life of a tunnel. And it's long compared with other things we deal with, like buildings and trains and so on. And significantly, it's long compared with an engineer's career. So if you think about an engineer who spends his life maintaining that tunnel, he's not really expecting to see any change in there. Now, if you think about some of the other things that influence us, for example, IT, that we embed in a lot of what we do, our parliaments, our government cycles, our typical research projects, they're much shorter wavelength things. And people expect to see many changes in a career if they're dealing in those sort of things. That mismatch is quite important culturally. That's partly why the asset manager who lives in the long wavelength thing can find it difficult sometimes to appreciate the high frequency events in perhaps the research community. It's also significant to note that our asset management strategies are only typically good for a very small proportion of the life cycle of the asset. And that's to do with how we discount money in our economic systems. So there's an issue we wrestle with. So where does that take us all? Well, perspectives on change. The innovator thinks he's got a great new widget, it'll be faster, better, shinier, give a generally wonderful new world to adopt his solution. The asset manager thinks, how much is it going to cost me? Do I believe it? Will it be reliable? Have I got to retrain everyone? Yeah, it's quite important to recognise those different viewpoints and understand that if we want our innovations and our technology to be successful, we've got to look at that soft skills side as well as the hard technology. So, how can we promote innovation? How can we support it? Well, there are lots of things we can do, and I think the mission of an organisation like CSIC is a vital building block in this sort of thing. But here's one example of a tool that I've found helpful in promoting change and improvement in some of the things we do. And it's the simple use of value as a modelling tool. And this is really something we've used often in areas such as procurement, where we're trying to get away perhaps from a simple dependency on price. So we're starting to say what we want is value, and we're starting to think about how we might define it. And usually we'll define value as being largely about the product, what it says on the tin it will do, but it's also got an element that's about confidence in delivery. It's about whether or not you believe it's going to work. Is it credible? That nice tin of snake oil that you were sold, will it do the things that it claims on the label? And value for certainly the purchaser, the end user, is usually about a combination of those things. So if we look at an illustration in the world of London Underground, if we go out to buy a design for a station, the product side of this is quite easy to define. There are things we need. We need to achieve a certain capacity. Perhaps we need to achieve legal compliance over fire safety, that sort of thing. We want it to be reliable. We want the price to be a manageable thing. But we also need to think about the confidence side. We need to think about risk and opportunity that might come with a particular offering, because that's part of the equation that we'll put together to decide whether something is good value. And the point I'm making here is that whether one is on the client side, if you like, receiving the proposal, or one is the proposer trying to promote the proposal, it's very important that we get some sort of framework, like a value model, where we can identify the things that the end user puts value on, and we can map the benefits against those. I see lots of proposals for things which on the face of it seem very clever, but where it's very hard to systematically map the benefits. So let's have a look at some of the things that have worked well in recent years around our system. Here we are. This is it's not actually recent work. This is 100 years ago, say, one of those escalator shafts going down. If you look closely, there are 4 men working in that face, lots of timber, some fairly hefty sized props in there. The thing I particularly like actually in this photo is this ladder. If you look closely, that ladder wasn't quite long enough, but happily they had a couple of pieces of wood and some nails. So an innovative solution. That's how we used to do it. You look at what we're doing today with a vast range of modern plant. I don't think it's necessarily the last word in doing this sort of thing, but we've come on enormously We now have sprayed concrete, so we didn't have to put people up to put timbers up everywhere. We have sophisticated machines capable of walking on all kinds of uneven surfaces, although you'll note we still like to tether it with a rope as well, just to be sure. These open up possibilities for doing the works in much safer ways and probably more efficient ways. And of course, if you look at projects like Crossrail, we have sophistication and high-speed production from some very clever tunnel boring machines. So there's lots of stuff going on in the plant world that's helping take us forward. Well, there's also quite a lot of small-scale stuff. This is the sort of the undramatic side, in a sense, but there's some wonderful ideas out there. The illuminated high-visibility vest. If you work somewhere very dark underground, that's a great idea. Or the little air cube there, which is simply a portable filter system, effectively. It sucks air in the pipe and forces it through a filter and helps control the environment where you're working. So there's good stuff going on at lots of different levels. But probably the biggest changes I've seen, I think, certainly over the last decade, have been around our sprayed concrete materials and technologies, and particularly in latter days on the waterproofing side. The picture on the right there, they're not actually spraying concrete, they're actually spraying a liquid waterproofing membrane onto the surface of the concrete, which will give us our permanent works waterproofing. And we've created some fantastic cathedral-like structures on Crossrail and around the LU system with these technologies. This is all stuff which 10, 20 years ago we didn't really have the capability to do at this level. We've also got better at mining into different areas. Victoria's always been a challenging site for London Underground. It's shallow, it's an area that was basically marsh and now has a lot of made ground, difficult material to work in, lots of groundwater, and a fairly unhappy series of misadventures have happened on various generations of tunnelling there. We're tunnelling again now at Victoria, and we've gone down the route of ground treatment. So we've used a jet grouting process, you can see the rig there, to inject and effectively mix cement into the soils present to form a solid block through which we've then driven our tunnels. And it's worked very successfully here. But this has been a great project for innovation because it's the application of the jet grouting in itself, the geotechnics is bringing new practices and developing skills in a difficult environment. But we're also doing it in conjunction with the BIM modelling. Down on the bottom left there, the forest of green spikes is the computer model demonstrating where all the grout holes have been put, where all the treatment holes have gone in. And that model has been an integral part of the process. We've used the model to assure ourselves that we've treated everywhere, and we've also been able to spot gaps with it as we've gone. So the two technologies have come together and given us a very robust solution. Ground movements are a subject close to my heart. We've got a great deal better at controlling the movement around our tunnelling. This part of intestines, as you might think at first impression, is actually one of our underground stations. This is Bond Street, right in the heart of the West End. And the sort of the grey or translucent tunnels and the red tunnels are the existing station. And the blue and the yellow are what we have to weave around through there. In the course of that, we've had to control the effects on our own assets, and particularly the escalators, which are very sensitive to movements. And we've been able now to repeatedly drive tunnels through this sort of system without causing serious disruption to many of the assets that we've gone under, or in some places we have had a degree of controlled closure locally, but we've been able to manage the consequences. So this is the sort of stuff we wouldn't have known how to do going back a number of years. And this is huge progress because this makes further works possible. If we move into the world of asset management, we've done a lot of stuff with different technologies here. But a lot of this is still at a prototype level. We're still feeling our way. So this setup is a laser scanning array mounted on one of our engineering trains. running through the tunnels, profiling them, building up a database of information about the geometry of a running tunnel. It's one of a number of technologies of this sort that we're using. Quite a lot of the challenges are not so much in the hardware, actually, that's on the train there. They're actually in the manipulation of the data. It's the vast point cloud models that one might extract from this sort of thing. How does the asset manager, who used to get a nice little handwritten report from his inspector, assimilate gigabytes of data and turn it into something useful? That can be the challenge there. And wireless remote condition monitoring. I know there are people here with a particular interest in this tonight. This is something, of all of the new technologies I've seen around the underground over the last decade, this is, I think, the one that is most clearly now, it's found its time, it's become mature. And we're seeing deployments on a very significant scale. So the image is here, the middle image is a tunnel we've just finished reconstructing, where we've been building cast iron segments, and the temporary works engineers on it are using wireless, actually Sensive units here, on magnets, which they can just plonk on the segment and have operating immediately. That's been great for working under time pressure and getting reliable data back. And we're now seeing developments like the Shell Centre reconstruction over there on the far side, going ahead with our complex assets underneath, having extensive wireless monitoring systems in there. We've now got to the tipping point where really the expectation, I think, is that a monitoring system in that sort of environment probably will be delivered wirelessly. Not long ago, in fact very recently, we would have assumed kilometres of cabling to make that happen. So this is a technology that, as I say, is finding its day. We move across into the design world. This is Bank Station, another project I've had the privilege of working on the last few years. And this is sort of taking us back to BIM and so on again, and 4D modelling. This video that's running, in the top left, it's just scrolling through the program. This is a job that's in the design phase at the moment. The top right is an overview of the whole 3D model of the station, and you can see areas of activity in green and orange there. Essentially green is underground and orange is surface work. And then the two images at the bottom are zooming in. And you can see that there's a complex geometry there. There's lots of scope for things not to connect. Fundamentally, doing this in a 3D virtual world is great for understanding the connections. Adding in the time dimension is great for planning how you're going to deliver it. What I would say is this is very old hat, what's running here now, because the designers are not necessarily using that on a 2D screen like we have here. They're actually now into virtual reality headsets to allow them to explore that environment that they're creating. So there's a piece of innovation which maybe a lot of our kids might be familiar with, certainly those of us who have teenagers, but it's showing how design practice is changing and adopting the new tools. And just while touching on Bank, it's worth mentioning that some of this sort of stuff has been stimulating us as an organisation to think a bit differently about how we manage some of these works. And this is a report into the procurement of the Bank Station project, which if you follow NCE and such like, you'll probably have seen bits about. But the point of this is we've been thinking here about creating the environment, changing the relationships between the parties to try and create an environment that allows people to draw out ideas, to make suggestions. And the last slide in this sequence, just to illustrate, of course, it's not just civil engineering that's going on. The two images on the left there are a pair alike. The top left is Baker Street Station. It's quite a famous painting of Baker Street Station when it was originally opened. You can, if you look, you'll see that it's dual track in there, two different gauges. And the lighting for the station was from arches that opened up to the street. Well, these days the street has grown and the arches have been blocked off. But we've just recently relit this station and put LED technology in there. It's been one of our pilots for that. So the lighting in the bottom picture is now a very modern installation of LED systems in the old structure. It's a nice demonstration of the old and the new together. And of course there are other things going on around the railway. We have things like platform screen doors now coming in and changing expectations of what stations should look like. We have other technologies, things like contactless payment, one of the big changes we've had in London, facilitating sort of different behaviours, making it easier for people to access systems and also access them in ways that are easier to manage for the operator. So there's lots of different areas of innovation going on within our system. So what about the future? We're doing quite a bit of change. We've got some positive results out of what we're doing. Where are we going? Well, what's going to happen to London? That's a huge question. This is London, not far off now. This is an architect's impression, one view of how it could look. Lots of green, a few more tall things. 2050, it's not all that far away, not in terms of the life of the civil engineering assets we're now creating, but we actually have quite a lot of uncertainty about what it might be like. What we can perhaps anticipate, rather easier than trying to imagine exactly what the city landscape will look like, we might have a bit more ability to spot what some of the issues are. And particularly when we get into sustainability and such like, we can start to anticipate where the pressures are going to be. This is a ranking of carbon footprint of a number of the world's largest metros, and we can see London is distinctly middle of the road in this particular community. Question that intrigued me when I first saw this was how did the ones at the low end of the scale get to achieve their low results? Well, the answer is either they run on nuclear power, form your own views, or in one case in South America, effectively they run on hydropower, which is a pretty elegant solution if they can reduce the carbon footprint to that level compared with anyone else. I just offer this graph as an observation of the sort of issues we have to face. I'm not quite sure that, well, I don't think I have a clear understanding of exactly where we'll be going with this. But some of the other effects of climate change and so on, one can start to anticipate. Back in 1927, my predecessors at London Underground liked to run this poster, advertising the merits of travelling on the tube and the fact it was warmer below. Nasty, windy, rainy weather up top. Well, these days, of course, we understand that we've actually heated up the ground quite a lot by operating the railway. We have some wider concerns as well about whether it's getting warmer anyway. And we've done a lot of work to try and develop a bit the infrastructure we have with things like better ventilation and borehole cooling and various other ideas. This is an issue which I think still has quite a way to run, and perhaps there are more technologies out there, more innovations that we're waiting for. What does amuse me, though, going back to the 1927 people, they ran that poster in the winter. In the summer, they ran that one. Which don't think we could really claim that one today. But it's nice to see the way they thought about the issue. Weather, of course, is a threat going forward. This is Hurricane Sandy. Picture on the bottom right there is enough to make your toes curl if you're responsible for infrastructure below sea level in a river valley near the sea. Some real challenges here. But again, scope for innovation. We look at this and we think London, Thames Barrier, keeps going for a bit. New York don't have that. They've just decided to invest in this technology, which has been around for a little while. Effectively, it's an airbag. It's an inflatable plug to quickly seal off the entrances to tunnels. quite a neat idea. I'd be fascinated to see one actually in operation. So the big picture, where are we trying to get to overall? At the end of the day, what we've really created at the moment in London with all the technologies we use, including the few I've illustrated there, is actually a pretty reliable railway. We're a great deal more reliable than we used to be. We still have targets to become much more reliable than we are now, but we're moving in the right direction. So our reliability is getting quite well up there. But it comes at a price. It comes at a price of effort. By that, a lot of that's related to our infrastructure. We actually have here in a typical tube tunnel a very complex set of quite ageing infrastructure. Lots of different systems in there. And therefore, to keep it all working, we always end up with lots of people in orange in the middle of the night, just for an hour or two, not the most efficient way of working, doing lots of stuff to make sure that we keep that reliability up. So that's achieving what we want now, but surely it's not what we should be aspiring to. What we should be aspiring to is finding ways of moving ourselves across the graph like that. We want to keep the reliability up, but we want to reduce the effort. We want to reduce the interventions that are needed. So maybe what we need to do is go to some very simple fixed infrastructure. Perhaps we could reduce an underground tunnel to this, just the structure itself to stop the ground coming in, and some sort of guideway perhaps, just to point the vehicle in the right direction. We could put all the rest of the technology on the train, and then it gets taken home to bed in the depot every night, and it's much easier to work on. It's kind of aeroplanes without wings sort of vision of a train, and a lot of our trains are not far off the sophistication of aeroplanes. You start thinking about guideways and so on, you start thinking about metallic wheels and rails. I started off with the Romans and started wondering what had changed in 2,000 years. Well, for the last 200 years, basically, we've been using metal wheels on metal rails. And if you look at the maintenance that's happening down those tunnels or on most railways, an awful lot of it is to do with wear on metal wheels and metal rails. Maybe we should be looking at some of these other systems. We've got to challenge what's accepted as the norm if we're really going to make step changes in what we do with our infrastructure. But we don't know which direction to go, do we? Because there is a different viewpoint to the very simple infrastructure. I'm pinching a CSIC image here. Instead of making the infrastructure super simple and taking everything back to the depot on the train, maybe we're better off working with the infrastructure, actually making it more sophisticated, but getting it to be reliably self-reporting. Maybe that's a better answer when the basic infrastructure is there already. There's a fundamental difference in philosophy there, but both approaches might be valid. We need to be thinking about what our vision is, which way we want to go on some of these decisions. So to finish, here's an invitation, and this is genuinely an invitation to all of you. Transport for London has a task. This is actually one of the formal sets of wording that we use. Our role is to keep London working and growing. It's not just about now, it's not just about the status quo. It is about serving the future when it's 10 million people in the city or whatever. And we're about making life in the capital better. We're about facilitating that change. But we know that the rapidly growing population is making this a hard challenge. What we've done as an organisation is looked at a whole series of areas where we believe there is a particular need for development and improvement. And this is where the invitation is there for anyone to suggest better ways for us to do things. So we're interested in customer systems, customer-facing things like the payment system illustrated there. How can we use technology to make that better? We are interested in value and sustainability, words I've been touching on through this talk. We're still the biggest consumer of electricity in London. There's something to think about. What can we do to improve our efficiency in that area? We're also a people business, not just our passengers, but also we have a large staff who make this system operate. We need to make sure that we give them the best tools, that we create the right environment for them to work in, and that will be changing as well as the demands on our organisation and our transport system change. And then if you get maybe a little bit more into perhaps more the nuts and bolts of the infrastructure engineering, of course there are safety issues there. I showed the platform screen doors earlier. With that image at the top just highlights the existing situation where the moving train is adjacent to the edge of the platform. There's lots of scope to develop safety improvements, innovative solutions. Delivery is a challenge to us. We're doing huge amounts of work, huge amounts of capital work around the system, huge amounts of renewal, while at the same time trying to operate more and more services. We're running more trains, we're running more through the night, we're running them closer together. Delivery in that environment remains a real challenge, and small increments in technology that might take the pressure off that could be a huge win for the organisation. And lastly, reliability. I've talked about that as well. We know there are lots of ways we can capture information about our assets, the performance of our assets. We know that our reliability is getting a lot better. We know that it's not perfect. To achieve the sort of performance we aspire to, we need to get better, and we need to recognise that technology and technical innovation must play a part in that. So TfL has developed what's been called the Technology Innovation Portal. If you go to the TfL website at the bottom there, you can go and find this portal, and it invites you to make suggestions, essentially. And if you put suggestions in here, they will be considered by people with appropriate skills across the business. Quite a number of us contribute to this from as and when suggestions come in. But also in there, something I'd encourage certainly anyone in, say, an organisation like CSIC to look at. There's quite detailed listings of the specific challenges that we see. I've just picked a few headlines there, but there are long lists of the specific questions that we could do with answers to. And going back to what I was saying earlier about the value model and sort of mapping ideas onto needs, there's probably some real scope there to go and map technologies and ideas that are around onto some of these demands. And we would be only too interested to hear suggestions that fit there. So, to close, there's a challenge for all of us here, I think. There's a challenge for us as the maintainers, deliverers, operators of the transport system to get the best that we can out of it. But there's also a challenge for the wider industry to look at the demands, think about the changes I've been describing in the city, and think about some of these specific needs and look for ways that we can map the things together to get to better answers. I'm sure there are better answers out there. We just need to put the pieces together. It's a good news story, though, for engineers, I think. It is a great time to be involved in this sort of system. It's a growing, thriving transport system, and we have opportunity to make it continue to grow and thrive in the future. Thank you.
Keith, I'm sure you'd be willing to answer questions. We have time for some questions if you have the energy. Who would like to ask a question of Keith? Jennifer.
Keith, I was interested by the juxtaposition of the CSIC slide showing the smart tunnel and everything with the potential for the future smart railway to actually be a very basic concrete structure with everything on the train. How realisable do you think that is, and what do you think the key steps would be to getting to it?
The issue we have in London is our thinking is very much associated with our established network. It's much easier to build the clean, simple, new, different thing. if you build it in isolation. We tend to have a mentality of sort of incremental growth of our system, so we always want to plug into what's already there. That's the issue. I think those new technologies are quite achievable if you can find a context to build them in isolation. I mean, look at the Docklands Light Railway, which is developed as part of our railway system in London, but it was built alongside rather than tied into the existing underground railway, and that allowed them to use some different technologies which allowed them to do different things and exploit different potential in that part of London. So it's quite possible to do, but you've got to sort of set the expectations, think about it from the start, otherwise you'll always default to incrementally adding to what you've got.
So you don't think that retrofitting, do you think it's possible to retrofit the existing system back to something that looks much simpler in the hardware, as it were?
I think it's a huge investment challenge, because to change a line, you'd have to change the rolling stock, the signals. One of our big drivers is not taking things out of service while we change them. It's a very, very big ask. I think to go for the clean, simple solution, it's much easier to build it new. And that perhaps means on the existing network, we get pushed in the direction of the intelligent structure, the self-reporting structure. If we can't simplify it, at least get it to tell us what's happening.
Okay. Any more questions? Yes.
Hi, Rick Holland from Innovate UK. One of the most important reasons why we're funding, or co-funding, I should say, CSIC, is because of the export opportunity. A lot of the intellectual property and the cutting-edge design and engineering developed here opens doors overseas. I wonder if you would agree with your discussions you've had with other metro providers globally. Are you seeing an opportunity for the UK to take a leading position on this?
Clearly. I do deal from time to time with other metros and usually sort of issues in my specialist field in them. And we are, as a metro community in London, we are very strongly positioned. We are right up there with a lot of the technologies, a lot of the asset management and so on that we are doing. And a lot of the applications of some of the specific technologies sort of comes quite naturally with that. So we are in a very much a leading position if you look in that community of metros around the world. Usually if you go out, well, in my experience, other metros I've been out to, you inevitably, you do the comparisons. And London is a high benchmark, very high benchmark. So it follows there is potential to communicate, to transfer knowledge and systems that are in London into those other worlds. I did a job on the Washington DC system a year or two back, where they specifically asked for input from London Underground, amongst others. And that was clearly the case there. Now, obviously, Washington DC is a very sophisticated modern city, but looking at the metro systems, their system was younger, a bit smaller. They hadn't had all the experiences. They hadn't been on some of the journeys of renewal and so on that we've been through in London. And when you put the two side by side, it very quickly becomes apparent that there is a big skill base here which is transferable. Metros have a life cycle 40, 50 years typically around the trains and the signalling, because they're the big systems that you need to regenerate every so often. There's an awful lot of metros around the world that were built or largely developed after the Second World War. Now, when you think about the timescales, there's quite a lot of metros around the world that have pretty much been through a life cycle, don't yet have the experience of regenerating themselves. That's the experience London does have. You go and travel on, say, the Victoria Line or the Northern Line. You're travelling on a railway that's been through cycles of renewal. And we have a skill set and technologies to do that, which are quite distinct from the ones to build it in the first place. So I think there's a lot of potential for transfer.
Yes, please.
Hi, Peter Adams from Highways England. I was just struck with your description of Docklands as a population, a working population. And I took from that in that there are a small proportion of people living there to working there. And in a way, there's parallels to that with London. And thinking about transport for London, for it to work, there's a lot of people clearly having to get to London to work, as well as people that are living within it. Where do you see the boundary of having to think about the transport challenge for London in terms of actually being able to connect, into the rest of the country?
It could be construed as quite a political question in the week where our boss has gone to take the chairmanship of the National Railway Organisation. There's no doubt, well, TfL has been quite open about its aspirations to develop and expand its rail offering and to offer a coordinated and integrated service across the area that works as sort of London the entity, sort of not worrying too precisely about the political boundaries. So clearly there is great interest from TfL to ensure an integrated system across that area. We don't have one delivery model. We have different delivery models for sort of the overground and the underground, DLR and so on. So it's a combination of them. But the integrated system, the one Oyster card that gets you around, those sort of things are clearly very important. Then you go back to the slide I showed from the Greater London Plan, because we're thinking quite a long way ahead with these sort of investment cycles. We're never going to upgrade everything all at once, so you have to go and target particular needs, and that does tie back quite closely then to what the Greater London Authority is looking at. So at the moment, one of the political changes is housing as an issue is becoming much more important to us. At the time when the first Crossrail line was being developed, the business case was sort of quite distinctly business driven, and one could see the connection between Heathrow and the City of London and Canary Wharf as business type entities. The schemes we're looking at developing now, like Crossrail 2 and various other things, are picking up different drivers. So I think I mentioned the housing potential up the Lee Valley. Well, that now is a driver to take a transport system there, but we're learning how to relate transport system development to promotion of housing, because that's not really something that's been a focus before. So it's quite an organic process. There's a lot of thought going into where to target the effort, where to get the benefits. It is being thought about at a sort of a London-wide, sort of make the whole conurbation work sort of level, and obviously with an understanding that also involves people travelling in from outside. But it's a complicated learning journey.
You got a question?
It is a challenge, and the different nature of the data that's coming in is, again, it's a learning process that's got to be gone through. We have to be quite careful when we specify new systems that our specification includes effectively the filtering down of the information. We don't want to know everything that's going on. We want to know when there's something we should pay attention to. So we have to be quite cute about specification, and that's something we're working on quite actively with some of these. But in terms of the bigger picture, I think part of your question was about how do we know we're responding to the right things across the whole system. And the root of the answer to that isn't really in the technology that you use to measure things. It's in the cataloguing. Well, certainly our philosophy has been about cataloguing the asset base. Historically, the problem that London Underground had, and it was a major issue when the PPP contracts were developed, London Underground didn't actually know what civil engineering assets it had. It knew that if you pushed a train in there, it came out over there. Didn't necessarily understand all the things it passed through. So over the last decade, a bit more than a decade now, a lot of effort has been put into cataloguing the civil engineering asset, and we now have a pretty robust, pretty complete catalogue of all of our civil engineering assets and most of our other forms of asset. So we know what we've got out there, so that gives you a database that's a reference frame. And once you've got that catalogue that you're confident is a complete listing, then actually it doesn't matter so much what type of information you're bringing in. You might be bringing something very high-tech in about one asset, and you might be doing another one the old way by going and tapping it with a hammer or something. But because you've got the picture of the whole catalogue, you know where you are, you know where you've looked, you've got quite a good basis to plan against. The danger is when you don't see the whole catalogue, and then you accidentally find yourself distracted and learning about loads over there and missing the one behind you. So cataloguing, I think, is the key to it.
Yes. Andrew James. If you had a reasonably unlimited budget and a free choice of anywhere in the world that you could build yourself a clean system, brand new, for the most impact of whatever sort you wanted, what would you build and where would you build it?
Well, there's a thought. If I was going, one could do all sorts of things, couldn't one? Technically, I like a challenge, like most engineers, so I wouldn't want the easiest thing to do. I think biggest question for me, if the options are really that open, might be, do I want to be in a city or somewhere else? I like working in cities, actually. Cities are fascinating things. I hope I've conveyed a bit of interest about the city itself in what I've talked about. So, a city would be stimulating. One would want to look for an opportunity to make a real impact, to change something. I mean, I think perhaps one would look at somewhere where the political context is changing, where there's development potential of that sort. I don't know. I think metro transport is a great area to work in. The sort of relatively high-speed movement of a lot of people can make so much difference. So I suppose regeneration, where there's social benefits. There we go. I have to think about that one.
Well, I think, Keith, you've worked very hard this evening, giving a wonderful lecture and also answering lots of questions. I thought you might have said tunnels under Cambridge. But, ladies and gentlemen, we've had a wonderful tour de force this evening from Keith. He started with the Romans, Hadrian's Wall. He took us through the history, through Brunel and many other evolving developments of the London Underground system, told us about changing materials, sprayed concrete, sprayed lining membranes, reminded us that innovation involves risk, and told us, of course, about the all-important life cycle. Those of you doing a PhD, don't be too dispirited that your life cycle is rather smaller than Keith's tunnels. And of course, reminded us about value. And I think that's probably the single biggest theme of Keith's lecture tonight, and how important that is. And also, very appropriately, given that we have a 2-day conference on wireless sensor networks, he also quite clearly told us that it is now the expectation that remote condition monitoring will be wireless. And you told us about how we should be like doctors, how we should look for symptoms. And you finished up telling us that the technology innovation portal that TfL run would be would welcome suggestions, and so that's a challenge for all of you when you go away tonight, thinking of suggestions to make to that innovation portal. And the final words of Keith were that there are better answers out there, and I'm sure that is absolutely right. There are better answers out there, and it's very appropriate for the CSIC annual lecture to have such a stimulating talk this evening, and we're very grateful to you, Keith, and on behalf of everybody else here, thank you very much.